Hello, morning. Today we are going to study electrical circuits. We are going to study the basics of electrical circuits. We know that in the current, electrical current, can be direct or alternating. We are going to study the difference between direct current and alternating current in another video. But today we are going to focus on direct current. First, we are going to study what the cell is. The cell is the device in an electrical circuit that stores all the chemical energy and transfers this energy to electrical energy to the circuit. When two or more cells are connected together, we call them a battery. Cells are the devices that push the electrons to move. Because what is an electric current? An electric current is the movement of the electrons. Electrons are particles in an atom, okay? And then the current, the electric current, is when these electrons are moving. In which direction that they move? They move in the direction from the negative terminal of the battery to the positive. So like this. Imagine this is the connector, the cable, and then they move from here to here, right? From the negative terminal to the positive terminal. This is the most simple circuit you can find, only with a battery or a cell, a switch, and a lamp. To make the circuit complete, we need that all terminals are connected together, as you can see here. When the switch is closed, then the lamp lights up. This is because there is a continuous path of electrons between the cell so that it comes to the cell again. They make a complete loop, un ciclo completo. So we are studying electrical current, and you know that to use electricity we need electrons to flow in the same direction all around the circuit. We usually use copper cables to form the circuit because the atoms that make copper have a very free electron in their valence shell, which is free to move around inside the metal and outside. These free electrons is very easy to move, which make copper so popular in connectors. It is so easy to move that it naturally moves, but we need the electrons to move in one direction, and we need all electrons of the cable moving in the same direction. To make that, we need a push for these electrons. If you want to generate light or heat or whatever, to do this we need the force that electrons should move, and we can try to do that by applying the voltage, which is the energy. Voltage is the pushing force. It's like the pressure in a water pipe. The more pressure we have, the more water we can make flow. The more voltage we have, the more electrons can flow. Normally, we don't represent the different elements in a circuit like this with realistic drawing. What we use are symbols. This is the symbol of a battery, the symbol of a switch, and the symbol of a light bulb. Here you have, right? Cell, the lamp, the switch, and of course, the connectors are wires or cables. Here you have more examples of different components in a circuit. Cell, battery, switch, lamp, buzzer, ammeter, voltmeter, motor, resistor, and variable resistor. Buzzer is what sounds. Motor is the device that spins. There are two types of electrical circuits. We are talking about direct current. Remember it. There are series circuits and parallel circuits. What are the difference between both, between series and parallel circuits? Look how the connectors are connected together. In a series circuits, this is the diagram, the components are connected end to end, one after other, to make a simple loop. They make a simple loop for a current to flow all around, from the battery or from the cell to the cell again. They do only one loop. What happens if we remove one of the bulbs of the lamps, or one of them blows, or it breaks? Okay, what happens is that breaks the whole circuit. Okay, the whole circuit is broken. Then, as you can see here, then the lamp is not here, and now the circuit is not complete. Okay, and then because the circuit is not complete, then the other bulbs goes up too. This is another circuit. This is a parallel circuit. The difference with this is that they are connected side by side, as you can see here, and what we make are two routes, two ways, two loops for the electrons to go through it. What happens if we remove one of the bulbs? If we remove one of the bulbs, because the bulbs are connected in parallel, then there is a remaining way for electrons to move. Of course, this part is open, it's not complete, but this is complete. Then the bulb remains lighting.